Okay, here is where hot water has gone through limestone rock, dissolved the limestone, and come to the surface. Some of the water evaporates, leaving super concentrated limestone-ish water behind, so that limestone has to come back out of solution and forms what's called travertine. Now, some of you have heard travertine if you go to Lowe's or Home Depot or tile stores. Why? Well, this is why. People cut it up and make it into tile. But this is what it looks like in its raw form. Now imagine this happening over years, decades, centuries, and millennia, building up meter after meter after meter over square miles. That's what happens, and then we cut it up. Here's a case where the same thing has happened, and I think this is in Turkey. And the travertine, the hot spring, is now surrounding a sarcophagus, a burial structure, which it appears also was made out of limestone, which is weird. You have travertine, which is really loose limestone, surrounding a more dense kind of limestone. And I put it in there again, weird. Now, if the calcium carbonate is made out of the organisms of those little coral, okay, let's go back to coral. Where'd we go? In the ocean, there are lots of little critters floating around, not just anchored to the sea bottom, and those critters also extract calcium carbonate from the seawater. When they die and go to the bottom of the ocean, they stack up and they make layers called chalk. It's all calcium carbonate, CaCO3. If we took a big barrel of acid and dropped it on here, there'd be a lot of bubbling going on. I have no idea what that thing is there. Like an old lighthouse or something, maybe. Pretty cool. The White Cliffs of Dover of England are nothing more than chalk. If you're to write the word chalk on the sidewalk with a piece of chalk, it's a little bit weird, but you're writing the word chalk with the organisms, with the bodies of the organisms that form the chalk. In the old days, when I would write that on the blackboard, I always thought about that. Thank those little organisms. Now, in addition to little organisms in the ocean, there are larger organisms in the ocean that extract their bodies from calcium carbonate. Your bones, by the way, have a lot of calcium carbonate in there, which is why you need milk and all that stuff, apparently. We end up with limestone that's made out of calcium carbonate. Fossiliferous limestone, it's called. And then sometimes there's just silica dissolved in water. When the water evaporates, it leaves behind chert, and special kinds of chert are called flint. Gypsum is another thing that's dissolved in seawater. We don't think about it. I believe is it calcium phosphate? I should know this. But this is gypsum in the form of selenite. And when water evaporates, or when it gets injected into little veins in rock, you end up with these little veins of gypsum in sandstone. This is on a mesa southeast of Holbrook, Arizona. I took this picture just a few years ago. Here's water evaporating in a lake, and people are extracting salt from it, the same stuff you eat. This is why having coal plants dump their stuff into the air, and that stuff coming down is not good, because one of the things coal plants dump out is mercury. But we let coal plants do that for free, because it's just good for America. Here's the rock salt flats in Bonneville, Utah, and again here are the White Cliffs of Dover in England. Back in World War II, there was a song called "There Will Be Bluebirds Over the White Cliffs of Dover, Just You Wait and See," where people were waiting for the soldiers to return. And one more type of sedimentary rock. This is bituminous coal. If you take plant material, you bury it so quickly that it can't decay, you keep oxygen away from it, it will get squished to peat. Looks like peat moss. That will get squished to a soft brown material called lignite. And then that, over centuries, millennia, or millions of years, actually millions of years, will be squished into bituminous coal, which will burn, but it's not as easy to burn as you might think. And it also stinks. Again, here are the White Cliffs of Dover. Sorry to bounce back and forth, but these are made out of billions and billions of bodies of little teeny sea organisms. It's kind of a big graveyard if you think about it. Ooh. Okay, features of sedimentary rocks. One, they have strata or layers. In this case, these are layers from hardened sand dunes. These are cross beds. But you can see that there are layers in here. And here is looks like an iPhone case that's made out of sandstone, but I doubt that it's really sandstone because it would break. but I thought it was just kind of cool. The Grand Canyon, sedimentary, because it has strata after strata after strata. If something's stratified like a society, that means the millionaires, Donald Trump and everybody are up here, and the teachers are down here. Stratified means layered. Here's strata. And also in sedimentary rocks you find fossils. You don't find those in igneous rock. You can find layers in igneous rock just because lava stacks on top of lava or ash stacks on top of ash, but they aren't really sedimentary layers. Also, in sedimentary rocks, you find ripple marks because if the water was part of a shallow sea or a lake or a river, there will be ripple marks. Geodes are from sedimentary rocks. Here are footprints. And this is up north of Flagstaff. If you're heading to Page, Arizona, which would be bad to do today because the road up on the way to Page collapsed as it climbs the cliff. But before you get to Page, off to the right, on the way to Tuba City, here's a place called Moenave. And here are some old, is it Diplodocus footprints, dinosaur footprints. Very cool. I think they're about a foot long, maybe a little longer than a foot long. Now, if you have any questions about a lecture, feel free to write me. If you have any suggestions, please do that too. Those will always improve the lecture, and I can just add them on at the end. Hard to believe, but that's it. Thank you for watching.